Hey everybody, welcome back to another baseline show. We have today the SRI BRI-3 Milestone 4 show. Welcome.
Awesome. Yeah. Thanks for joining. We'll also have a blog and some other content coming alongside this big achievement. And I'm sure the team is excited to keep powering through this hefty beast you guys have been working through the last year and a half-ish. So we have some of our work group members here, as well as a few that were receiving the grant. And as the final step of the grant for this milestone, we'd love to dedicate this show to seeing what was worked on. So I will hand over to you, Ogden.
Cool. Thank you, Sonal. Thank you, Yoav. Yeah, it's been quite a long time since we started. We managed to go through the first 2 milestones and set up basically everything so that we can have counterparties who can interact in a manner where they have an encapsulated work group and agreed work steps. And this milestone 4 was all about trying to pinpoint a really simple use case and then trying to implement baseline. What baseline is for that use case, which is to try to synchronize state using the BPI. We intentionally wanted to be as limited as possible because we use this milestone mostly to try to identify what would be the best path then to really finish the simple reference implementation, generalize it in milestone 5. So I'm going to share my screen and take everybody through the grant, through the goals of this milestone, and then through the process of how we got to select the use case and then how we implemented it in the end. And I would finish with the plans for milestone 5. And of course, other team members hopefully will jump in to add to the description. So milestone 4 was titled BRI-3 Beta. And the idea was to support agreeing on a shared state for a single happy case. At that time, we didn't know what that happy case is. So that we can, in the end, when the work steps are executed for that happy case, we can have proofs generated and stored, and that can be verified by participants. The first big thing we had to do is to agree on the use case, and through that process, we managed to come to a bunch of to decide on a lot of design choices. We in the end implemented in the BPI. What we decided to go for was a really simple thing, basically 2 counterparties that are exchanging invoices, so a seller and a buyer, in regard to an invoice document that accompanies some kind of a business transaction between them. And that invoice document is really limited in a sense that it contains the IDs of these counterparties, the ID of the invoices in their system of record, the amounts, the issue and the due date, status, and some of the items that are part of that invoice. The idea is so that we can take now this predefined payload and then take it through a number of work steps that they previously agreed to, which end up in them having proof that they have the same invoice in their system, and also a third party that can verify that that invoice went through these state changes, so to say. And then we split the workflow into 3 work steps. So the first one was just to propose an invoice. So a supplier would submit a candidate, so to say. Then we would have the other party, the buyer, verify it. And in the end, the buyer would be able to mark that invoice as paid. The work step 1 is really the important one, because the other 2 are basically doing the same thing, just changing the status in a different manner. So we're going to focus on work step 1, and then we invented some business rules that need to follow the execution of this work step. For example, we need to verify that this invoice when it's proposed as a new candidate, it needs to be in a status new. All the fields apart from the buyer invoice ID need to be provided. There is some verification that the amount on the invoice is the sum of all the item amounts and the prices. And that it is unique and not part of the state, and that there is a signature of the supplier which is present and valid. Later on, the other work steps would just basically apply similar rules where they make sure that the state transition is, for example, happening from new to verified in some predefined order, and that the other fields are provided, and that some of the fields, older fields, are not changed. What was the motivation behind picking up this use case? First of all, it's extremely simple. So we could just focus on building the thing without thinking in this milestone about all the edge cases and all the different payloads and all the different business transactions that could exist. So we deliberately left that for milestone 5. But it's also interesting because if you think about two counterparties exchanging invoice data like this, if there is a need for a third party now to do something with that invoice, if, for example, you will have a factoring institution, financing institution that wants to finance that invoice, then you could use the artifacts that are produced by the BPI or by baselining to prove to that third party that the invoice is valid, for example. Yeah, so, and on the right-hand side, if you see as I scroll down, there is quite a lot of comments because we started from a blank piece of paper. We started writing down the simple idea. And then what we wanted to do, encapsulate in this document as well, is the design from that payload that we agreed on. How would that be represented in state storage in the BPI and so on. And we discussed a lot of design decisions here that were followed by opening issues, additional discussions, rewriting issues. And it was all conducted in a manner that anybody could, transparently, so that anybody could participate. If this is interesting to listeners, we would like to invite anybody to join the effort from Milestone 5, as we will be having even more documents and discussions like this, trying to craft the final product, the simple reference implementation. As we discussed, and once we had something which we deemed good as a basis, we started crafting GitHub issues, and these were the issues that were the start, served as a starting point for implementing Milestone 4. Of course, this was not done immediately. We continued throughout last few months working on this document and also opening new issues, rewriting them. So, but we tried to track everything we could here. Okay. Yes, you can even see how we our discussions around state storage, localization of the payload, design decisions, which libraries to use, so on and so forth. The link is in our repo, but we can also share it afterwards if anybody is interested to go through and look how this design process looks like. And I would jump into code base now to try to lead everybody through execution of this work step 1, right? If that sounds okay.
Sounds great.
Okay, so in Milestone 3 we had you could set up as an entity, you could set up your BPI subject or a representation of this company in the Basel protocol instance. And then through that BPI subject, you could have a work group that you could join a work group, and you could do all that administration around identity and work groups. And what we introduced with Milestone 4 is that now you can submit a transaction that contains the payload, and then there is a what we call a virtual state machine, which basically picks up all the transaction candidates in a given period in batches and then tries to execute them. And I think that's a good entry point here in the task scheduler agent, which is basically a background task implemented in SJS as a cron job. There is a configurable cycle in seconds that will just execute VSM cycle command, which basically tells command handler that it can trigger execution. What we then do is we get all the candidates for execution, meaning we go to the DB and we fetch all the transactions that are in status initialized. If they are in status initialized in the DB, that means that they are created either through the REST API or through, for example, NATS messages. So a BPI subject will initiate NATS message containing the specific payload containing the transaction and the payload from the use case, the invoice itself. This also means that they already went through all the necessary validation so that they can be in status initialized, that they contain the right signature, and so on and so forth. Once we fetch the candidates, again, the batch size is something which is configurable. We go through each one of them, and for each step, we update the status of the transaction to avoid any double execution. So we mark them as processing, we validate them for execution. I'm not going to really go into details. This can be seen in the repo itself, just through the high-level flow. And if they are valid, we want to see to which work step of which workflow does this transaction belong to. Because when you are, for example, executing, you want, as a company, you want to propose a new invoice in our use case. What you would do is that you would create a transaction error system that needs to tell the BPI, here is the payload, and I want you to execute this exact work step in the BPI with this payload, right? So this would be prepared by your system, and you would then send it, for example, as an NATS message, and the BPI can then verify that that work step exists, and then it would try to execute the transaction. And we can dive into the transaction execution part. So this is in the transaction agent, in the transactions module in the BPI. What we do here is we first fetch we first Merkleize the payload, meaning basically that we take the invoice properties as they are and try to construct a Merkle tree out of it. And that's the first part of the transaction result. Once that is done, we use a convention that we agreed on previously that will look for the circuits or the circuit artifacts or zero knowledge artifacts in the file system of the BPI based on the name of that work step. When I say zero knowledge artifacts, I mostly mean so the the compiled circuit and the keys, the paths to the keys. This is a convention which we agreed on in order to be able to support later on general use cases. Because currently, what the state is in the BPI, you can just execute this specific use case, so this specific payload for exchanging invoices. And in Milestone 5.5, we want to open up the BPI, so to say, to allow for any kind of payload and any kind of business rule to be executed through the BPI. And in order to be able to achieve that, the approach we took is to allow the counterparties or workgroup participants to provide their own circuits. So the flow would go something like this. You have, for example, two companies, they have some kind of a business process between them, they want to baseline. They would agree on the business rules that need to be followed and would construct a circuit, a circuit that has those rules and that expects some kind of a payload. And then they would upload those artifacts, so the compiled circuits and the keys, to the BPI. Based on a naming convention, which might be changed and might remain like this. They would just need to name these artifacts in a specific manner, and then these artifacts would be connected to the work step that needs to be executed. So in our simple case, if you send a transaction with work step 1, the BPI is going to look for the artifacts based on the path here. You can see it here on the left-hand side. So the zero knowledge artifacts, circuits, and then we see work step 1. And it's going to find these artifacts, and then it will go forward to try to execute your payload against these circuits. And this is what's happening in the method here, the create witness method. Currently, what we have is a hard-coded translation of transaction payloads into the inputs for the work step. And you can see two comments here that are left, again, for milestone 5, where we want to generalize this as well. So at the moment, you would only be able to execute, as I said, our specific use case, but in milestone 5, instead of having this hard-coded, what we want to do is we want to again allow the participants to provide, let's call it an explanation to the BPI, how to translate the payload of the transaction into the inputs that the circuit they provided expects. And again, we agreed on an approach to use a JSON schema for that. We are designing now the structure of that schema, but it's just going to be a single file that's going to tell the BPI, if you receive a payload like this, with these properties, translate them into the circuit inputs that look like this. And we will be loading that schema here and then trying to translate the payload into inputs. Once the inputs are ready, we basically execute the circuit. Currently, what we do is we use Snark.js. And based on the paths provided, as I mentioned, and the inputs, we can generate the proof. For milestone 5, we will probably just stay with Snark.js and supporting these formats. But this is then a topic maybe for the future to allow for different libraries and different approaches for zero knowledge. But yeah, topic for the future. The execution of the circuits creates the proof and returns the public inputs. And this is the object we call a witness, which is then returned to the transaction agent, which is executing the given transaction, and stored in the transaction result witness. We take these results together with the hash of the transaction, and we return all of that to the virtual state machine. If anybody wants to jump in to add, if I missed something and I'm moving too fast, please feel free anytime. Okay. Okay, so now what happens is we are back in the virtual state machine. We execute the transaction. In case that there is any kind of error anytime, we will just publish an event saying that, and we will update the status of the transaction to aborted. And that's more or less it. Otherwise, we continue. now we go to state storage, and maybe it's better to explain this through the Prisma schema that we have, where you can see the database structure, basically. So we're using, as people probably know, we're using Prisma as an ORM, and in the schema we have defined the entities that are tracking the state. Mainly that's the BPI account. BPI account is related to a workflow, and it's responsible for storing all the state of that workflow. So every work step which is part of the workflow should interact with that given BPI account. And we have 3 places where we have state stored in the BPI account. That's the state tree, the history tree, and the state tree leaf value. So we can just jump into these 3 quickly. So they're the state tree and the history tree, they are BPI Merkle trees. They are basically marshaled Merkle trees with a given hash algorithm. And we use Merkle3.js to perform this marshalling and unmarshalling. So if we want to update the tree, we would read the content of this table as text. We would then translate that into a Merkle tree from the Merkle3.js library, and then we would perform operations on it, and then we just throw it back into the DB as text. So the same goes for both the state tree and the history tree. And when it comes to the state tree leaf value, this is how we store the actual outputs of every execution of every work step connected to that, for example, state tree. So in the state tree, each leaf would be the hash of the root of the Merkleized payload and the witness, and that's all there is, right? And then in this table, which is connected to the BPI account, we store the leaf index and the value, and then you have here the related Merkleized full Merkleized payload and the full witness, which can be used then for validating the current state, and also validating the history or the state changes. Okay, anything to add, Shri, Keith? Cool. What's important to note as well, the part where we expose or allow somebody to validate the state in the BPI is through the anchor hash, which basically is just an exposed endpoint that allows a third party to check that for a given leaf value in the state tree, there exists some kind of state, and we can expose to them the content of this table here, so the state tree leaf value, and through that leaf value they can verify that they, for example, have a invoice which when Merkleized is the same as the payload located here, and if they execute independently the circuit that's part of the work step, they should be able to get to the same witness, thus verifying that the state in the BPI is the same as in their system, and that it went through the same state change. Now, this is mostly what Milestone 4 was about. Just let me go back to the command handler. So we execute a transaction, we then store the new leaf in the state tree, We then again store a new leaf in the history tree. So that's just the state tree root, which is added as a leaf. And before marking this transaction as executed, what we do is we store the transaction hash on the on chain, or as controlled state machine, so that we have a dependency, or we have a trail. How was what was the next state transition that happened, the last state transition that happened, that can be verified by a third party. Currently, this is really crude, meaning that we just have a simple toy contract that would store this information in a simple map. And one of the streams in Milestone 5 is going to be to expand on this on this contract, so that it will be used on production level for these purposes. The transaction is then marked as executed, and we then inform through using events, inform the counterparties about the result. And by doing that, we've finished one transaction execution, and we can move on to the next one. These events, again, we are just relying on the infrastructure framework provided by Nest.js. So each event has a handler that then can perform independently certain side effects that need to happen after the certain event has been thrown. And again, we strived, for anybody that's going to look into this code base, Milestone 4 was all about getting this initial happy flow to work and understanding everything that we need to do in order to have exactly the state needed that's going to allow for verification from the outside. So we took a lot of shortcuts in different places of the code base, and now with Milestone 5, the idea is that we can work much more on that technical depth, apart from now generalizing and allowing the BPI to support various payloads and various business transactions. We will be tightening up the tests, trying to make sure that the SRI is going to be robust for production level usage, and yeah, cleaning up, making the code prettier. All of this flow is captured in a single unit end-to-end test so far, which is here in tests. It's the SRI use case. Unfortunately, I cannot run it now because I've been playing around with the code base, but it should be straightforward based on the README to just execute the end-to-end test run. What it does, it's explained well in the name of the tests, but it basically simulates the SRI use case from the document that you saw. So we have two external BPI subjects, and there is a work group, and then these subjects are added as participants to the work group. Then somebody sets up a workflow with a work step in that work group, and then there is a transaction being created. So it's being submitted through the REST API here. The other way would be through a Nats message. You can see the payload here. So that's the payload from the document, the amount, the dates, the status, and the items. And then we just wait. The test just waits for some amount of time for this virtual state machine cycle to execute. And we want to verify that we have entries in the state and the history tree in that resulting BPI account connected to the workflow. Yes, it's really crude, but it verifies the flow works. And also, again, Milestone 5, not to repeat myself too much, but Milestone 5, one of the streams is going to be to expand on the end-to-end test suite and show that we can support various different business transactions through through the BPI with the tests. Okay, I would, if no questions related or no additions to the code base, I would maybe jump in a little bit into milestone 5 in more details. What do we plan, what we already started working on, and what do we plan to do next? So the best way to see that is through the baseline issues. Oh, sorry. How we work is that we mark issues with milestones to which they belong to. So as you see, milestone 4 completed, and milestone 5 we already have 11 issues open. This is the one stream that I already mentioned in the beginning. So how to a mechanism to attach any given circuit to a specific work step, and then to a research way to allow us to support general use cases. So we already started working on these, and the general consensus for now is that we go with this JSON schema. It's going to be helping the translation between the payload and the circuit inputs. We have a bunch of some smaller technical depth issues just to make the code base more uniform, such as this one, or transactions that are missing creation dates, or extracting some variables to environment, and so on. And then we have some bigger ones, again, technical depth. So currently our unit testing is rather cumbersome, because there is a lot of boilerplate setup that needs to happen before you can actually unit test the functionality, and it's prone to error, and it's painful, and that usually makes devs skip or not write enough unit tests. The goal is to avoid all of this just by mocking the underlying Prisma client. There are already libraries that do this, and hopefully through that setup we can really simplify writing unit tests, and then we can work a little bit more to get to a better place with coverage when it comes to unit testing. So that's going to be one stream. And of course, this is necessary because the final product, so to say, SRI after milestone 5 is supposed to be a production ready tool. Although it's a limited implementation of the standard, it should be production ready. So it's necessary that we have test coverage. Then we have another shortcut we took, and that we now need to deal with, is that we need to support atomic transactions. So currently what could happen is that in a command handler that deals with some business logic, if there is a failure, you could end up in a state which is inconsistent, where part of the business logic is applied to the DB, where the other part is not. And we discussed approaches to do this, and this is going to be one stream for somebody to design and implement across the board. And the approach to allow that we, through an invocation of a single line in the end of the execution of the command handler, either store everything or discard everything. We then have an issue with mapping, which is currently not done properly and which is very cumbersome. Needs to be fixed. Prisma is a little bit specific when it comes to usage with automapper. It has some shortcomings, so we need to find a way around it, and again apply it across the code base. Another stream, and then we have the the whole part related to smart contracts, and how is this part of the BPI going to work? Who's going to be doing the deployment of these contracts? Will we have a single contract that's going to be pair BPI that's going to store all the necessary state, or do we want to have a separate contract pair workflow right, or pair over group. There are many considerations that we need to take into place, especially since state storage on a level on chain is something that needs to be paid for. So in that sense, we need to think about a better and best approach and then implement it. That's just the start. So there are a bunch of other streams that we need to be working on, but in general, you can think of as one stream to support the general use cases, and then one stream to deal with technical debt of various kinds, and then one stream to work on the on-chain part of the BPI. And hopefully, with these streams complete, we will be able in the next few months to have the SRI implemented and ready to be used. Any questions so far? Or anybody has to add something? Maybe one good thing to add is that we are in need of support more and more as we work. It's the problem is getting bigger, it's getting more interesting, and we already have some people who joined the grant efforts, which is great. We're seeing more activity from different people on the repo, and I would like to invite anybody who's interested to join and be part of actually building an open source protocol from scratch, which is a unique experience in my eyes.
I just want to add that anyone who wants to join us, and they are confused about how to get started and where to look in the code, I would really suggest that you first study the SRI document that Ogden showed at the beginning of his presentation. Then go and see how that document gets translated into the end-to-end test that is there inside the SRI. And I think if you just follow the path that is laid down, you will be very easily able to find how the entire code base works, because we have tried really hard to ensure that whatever the variable names are, the function names are, they are very descriptive of what they are doing. So it will not be very difficult for anyone to actually jump in and get their hands dirty. And regarding the setup of all the artifacts for example, setting up for the circuits, zero knowledge circuits, there are additional documents inside the README. So you can go and refer and actually set up your own BPI implementation and run the entire code base.
Yeah, that's a good point. We would also like, as an end result, to have something which is easily used by anybody who is interested. So there will be a part of the effort during Milestone 5 to try to create a really simple UI that's for demo purposes, but also for people who are not familiar with command line and these things, to be able to set up something and interact with the BPI to get a feeling of the functionalities that it can provide. Cool. I think we covered on a high level what Milestone 4 was about. Yoav, do you have maybe something to add, or questions, or anything else you think we missed?
I don't think so. I think that was pretty well encompassing. Maybe Mark or Sonal, from kind of a less informed perspective, is there any questions you guys have that you don't think was kind of covered?
No, I think it was a pretty good overview. Great job by the team. very exciting. Getting closer and closer to finishing the SRI. It's a big accomplishment. A working
Yeah.
SRI for the people. Very exciting
for
stuff.
for the people. Yeah, exactly.
That's right.
It's going to
Yeah,
be
agreed.
super interesting doing the efforts, trying to get companies on board, that can test it out, that can implement it in their workflows. Interesting times ahead.
Thanks for walking us through that. And I guess, what is the timeline looking like for the 5th milestone?
So that's, I think we missed every timeline that we gave previously. So it's really hard to tell, especially since we are working in an open source setting where people have other responsibilities as well. So it's hard to say that. From the amount of work, I believe it's less work than what we did for milestone 4. And I think the path is much clearer now. So we're not, more or less, we're tightening things up. So I would say that it's going to be faster. But again, that really depends on a lot of different factors. I do hope that during October and November, we can wrap it up.
Yeah, I would agree that it seems much more kind of from the previous milestones. It seems like we have a much better idea of where we need to go and what needs to get done. Everything's kind of been laid out already thanks to the previous milestones. So I think we're in good shape.
Yeah, exactly. I don't think we have, when we started milestone 4, there was a lot of unknowns. And then we had to do a lot of back and forth in communication and brainstorming to find a path forward. And now I think all of these topics are resolved. So we just really have some minor decisions that we need to make. So it's all about coding, more or less.
Best part.
But I think we had optimistic estimations for each of the milestones. So let's just not go there.
Yeah, be conservative.
Yeah.
Awesome.
Shri, anything you'd like to add in?
Oh, I'm just like excited to actually see all the ideas that we have finally coming together and making it a working implementation. So really just excited.
Cool.
Yeah, agreed.
All right. I think that was a great show. It's showing us like the real work going on for the standard. And I think this was a really important high priority for the last few months, just to finally have a fully open source implementation for people to use. And I think we'll see lots of exciting traction coming from the completion of this work, like the interop work that begins soon after, as well as some more outreach work that can kick off because there is actually something tangible that can be picked up and leveraged, which didn't exist before. So awesome job to the work group. We look forward to continuing to have you on the show to see how the rest of the project wraps up. And like you mentioned, for anyone watching, I think the work speaks for itself on why this is super exciting to be part of. We've had devs from various companies or students studying computer science joining on different parts of the effort. And the team is very hands-on with helping onboard people to different aspects of the project based on their experience or interests. So there's definitely room to get involved if you're interested. And hopefully there's an easy process to get started that you'll find on our Slack, on our website, and just reach out to us and we'll loop you in. All right. Thank you all so much for a great baseline show. We will see you on the next one.
Thank you, everybody.
Thank you.
Thank you.